6, 3, 2 and 2. And matrix C, which is 4, 8, 3 and 6. So what it's asking is calculate the determinants for each of the following. So determinant of A, I'm going to write it out this time just to start with. Remember, our formula for determinants is AD minus BC. So for determinant A, matrix A is 3, position D is minus 3, and we take away 4 times 2. So 3 times minus 3, we get minus 9, we take 8, so we should get minus 17. For matrix B, determinant of B, AD minus BC, so 6 times 2 minus 3 times 2, so we get 12, take 6, so we should get 6. And last one, determinant for C, so 4 times 6 minus 8 times 3, and we should get 6, 12, so that should be 0 in total. So that's example 11. So that's all we need to do, is just find those determinants. So it's just as simple as that, just AD minus BC, the position of A, D, and B and C. So I'll just write that down here as well, just for your notes. So position A, B, C, and D. Okay, so that's the elements. Next question is looking at example 12. So we've got the matrix A equals 3, 5, 2 and 4. So 3, 5, 2 and 4. And what we want to find is the inverse of A. So as I said in the previous video, first thing is probably find what the determinant of A is first, just to break it down and hopefully less steps, or easier for us. So 4 times 3, or 3 times 4, minus 5 times 2, and we should get positive 2. Okay, and then we can say our inverse of A is 1 over the determinant of A times, I'll write it all out, so D minus B minus C A, put our numbers in, so 1 over 2 times D, which was 4, minus B, so minus 5, minus 2, and 3. Okay, so that's that one, and that one was that one. Okay, so just see how they swap around to get that resulting matrix. Now you can go one step further, leaving it like that is okay. Another option is to get rid of that half by putting it into the equation. So it'll be 4 halves minus 5 halves minus 2 halves and 3 halves. Okay, you can leave it like that, or you can simplify it a little bit more. 4 divided by 2 is 2. We'll just leave that as 5 halves. That'll be minus 1, and that'll be 3 halves. So it's up to you what you do. Either way is okay. I prefer doing it this way because when we multiply, it just makes working out a little bit easier, but not all the time. So it's up to you what you end up wanting to do. So that's example 12. So that's all we need to do. Just as a side note, sometimes the determinant is actually written as a little triangle. So if you see that little triangle, means the determinant. So I'll just go through another example. This is example 13. So example 13, we've got the matrix A and B. So A equals 2, 5, minus 1 and 3. Matrix B is 16, minus 3, 3 and 7. And I want to solve for the unknown x. For A, x equals B, and then yeah, so we'll do this. This is part A. Sorry. Okay. So we start with ax equals b. Well, let's just put in the numbers. So 2, 5, minus 1 and 3. Okay, times by x, y, and that equals matrix B, which was 16, minus 3, 3 and 7. On the side, I need to work out what my inverse of A is, but before that I need to work out what the determinant is. So determinant of A, 2 times 3 is 6, take away 1 times minus 5, should get 11. So my inverse of A is 1 over 11 times, and we swap A and D, and these become negative. So negative, negative 1 becomes positive. Okay, again, I like just putting in the fraction. So you can leave it like that, that's fine, if you want to do that. Okay, so that's my inverse of A. So because I've got A inverse on the left, I have to multiply it by A inverse on the right. On the left, on the right hand side. So I multiply by the inverse here, multiply by the inverse here. When I do that, this one and this one cancel out, so I'm just left with x, y. And then on the right hand side I have this matrix here. So 3, 11. And that's multiplied by matrix B, which is 16, minus 3, 3 and 7. Okay, fair bit of working out using your trains. So 3 times, or 3/11 times, oh actually, it'll be this one times this one. And we add this one times 16. Okay, so that's just by using our trains. I'll draw the first one in. And it goes all the way down into there, ends up over here. Okay, and then I multiply it out. You can pause the video here and fill out the rest by yourselves. Good practice for multiplying matrices. Once you've done that, should get the answer 3 minus 4, 2 and 1. Okay, so we can say matrix X equals this here. So that's part A. So that's using inverses, determinants, so just combining everything together, really. Part B, we have ax equals 13 minus 1. So similar case as before. I've got matrix, or the inverse of A. We don't need to do that again, we've got this here, so 3/11. So I might as well just copy that. So there's matrix A, we're finding AX equals okay, and again, because we've got A on the left, we need to multiply the inverse on the left. So we multiply it by the left on both sides. These two cancel out. We get X equals our inverse A times our other matrix. Again, we've got some multiplication. So this row times this column, this row times this column. Do some working out. Again, good practice for you. And you should get 4 and 1. Okay, so that's part B, that's all it is. So again, just practice using our rules. So if we have to multiply on the left, we have to do it on the same. That's really what this task is asking you to do. So just identify that. So if it was the other way around, so it might have been XA equals B, so then we'd have to multiply it by on the right hand side. Okay, just as a side note, so that's all we need to do. So that's chapter 8.5. Have a go at some of the questions now by yourselves. Feel free to ask any questions. Thanks for watching.